Myself, M. Bhanuprasad, working as Assistant Professor in Department of Mechanical Engineering in MVR College of Engineering and Technology. Today we will discuss about intermediate alloy phase. So, intermediate alloy phase is formed when the compound lose their individual identity and characteristics and properties to large extent is known as intermediate alloy phase. So, the compound lose their individual identity and characteristics and properties to large extent is known as intermediate alloy phase 1. So comes to the second point one. Intermediate alloy phase as crystal structure different from those of elements and are formed intermediate range of composition is known as intermediate alloy phase 1. So it is the intermediate alloy phase 1. When it will be happen means when the compound lose their individual identity and characteristics and properties to large extent is known as intermediate alloy phase 1. So in this intermediate alloy phase 1 we have the one structure. The structure is nothing but different one from those of elements and are formed intermediate range of composition 1. So next topic is the composition of intermediate alloy phase 1. Intermetallic compounds, intermediate metallic compounds, interstitial compounds, and electron compounds. Generally, we have the three types of compounds. One is intermetallic one, second one is interstitial one, third one is electron compound one. See here, first one, intermetallic compound, or we can call as valency compound. These are formed by two metals are exhibiting opposite metallic element is known as intermetallic compounds. There are two elements. Two elements are soluble in each other one, but existing or exhibiting opposite metallic elements is known as intermetallic compounds. There are possess pure ductility and poor electrical conductivity and complex crystal structure is known as intermetallic compounds. So see here structure of intermetallic compounds. These are the intermetallic compounds. These are high brittleness material, poor ductility and poor electrical conductivity it will be formed. So it is the intermetallic compounds. So next one is interstitial compounds. So what is the interstitial compounds means? Interstitial compounds are formed between transition metals such as sandanium, titanium, tungsten, iron with hydrogen, oxygen, carbon, boron, and nitrogen. So this is the interstitial compound will be formed. So interstitial compound will how it will be formed means some example one see here. So it is the interstitial voids. It is the number of crystal one. In this crystal one, we can fit into these atoms one. So then the strong bonding will be formed. The strong bonding is nothing but interstitial compound will be formed. So these are the some example on all these atoms are nothing but such as sandanium, titanium, tungsten, iron. All these are. So in this total metals one, we are fitting into the carbon atom. So after then what happened? The strong bond will be formed. So it is the interstitial compounds. So in these interstitial compounds one, we have the high strength and high toughness also we can see. So next one is comes to the some example of interstitial compounds are extremely hard and high melting point one. So extras some examples are titanium and carbon one, and W means tungsten and carbon one. So these are the examples of the interstitial compounds. Next one is see third one is electron compound. In electron compounds, normal valency laws are not obeyed, and they are based on electron to atomic ratio one. How the electron compound will be formed means definite valency electron to the number of atoms ratio is called as electron compound. Definite valency electron to the number of atoms ratio we are consider the electron compound one. So this is the electron compound one. So next comes to the next topic one, grain size determination one. So yesterday class we will discuss about what is the grain size and what is the grain boundary. Comes to today one, grain size determination one. The following methods are the grain size determination one. What are these for methods means see here. First one is comparison method. Second one is intercept or high-end method. Third one is planimetric method. So we can see first one is comparison method. What is the comparison method? The ASTM. American Society for Testing of Material has discovered comparison charts with the different grain size one. So it is the grain size means some example one grains. We have the small particles. Some of the small particles we have the grains one. This grains is a determination one. How can we find out the number of grains inside the solid body or inside the metal means? So we have the some methods. By using these methods, we can find out the how many grains in the solid body. So the first one is comparison method. In comparison method, how can we find out the grains inside the solid body means? So we have the some standards. So the standard is nothing but ASTM, American Society for Testing Materials, as it is derived comparison starts with a different grain size one. So the grain size number n ranging from 1 to 10 based on the following relation one. What is the that relation means? Capital N equal 2n minus n, 2 power n, sorry amma, it is not 2n, 2 power n minus 1. So where small n equal, capital N equal number of average grains, next small n equal number of ranging from 1 to 10 1. So this one we can call as comparison method, comparison method. So next comes to the second one, intercept method. This intercept method, a straight line is drawn through the photo micrograph that shows the grain structure one. So in this one, so first one is the comparison method one. We have the standard formula. The standard formula is nothing but capital N equal 2 power n minus 1, 2 power n minus 1. So based on this formula to find out the number of grains in the solid body. So next one is come to the intercept one, intercept method one. So intercept method one, a straight line is drawn. Some example one in this method of straight line is we can drawn through the photo micrograph onwards. It shows the some grain structures. So it is called as intercept method one. See here how they are find out the grains, number of grains, how they are find outing what are the procedure means. The grains are intersected by a line is counted. So the grains intersected by a line is counted. That is the first point one. Next one is the grain touched by the end of the line are counted as a half grain. Some example we can strike the one line one. The line in one, the grain will be touched, the we are consider the on counting. The counting is nothing but half grain one. Some example I can draw the one straight line like this. The straight line one, the straight line ending one we touch the grain one, so we are counting as half grain one. So that is the intercept method one. So countings are made on at least 3 fields to assume reasonable average accuracy of the size of the grain one. Countings, how we are consider the counting means at least 3 fields we can consider the, after then only we are considered as average accuracy of size of the grain one. So it is called as intercept method. Intercept method, what is the procedure means? So in this method one straightly we can draw the on line one. When this line one, the end of the line one, when the grains will be touched, after we are considered as half grain one. So how many times we want to draw this line means 3 times, at least 3 times we can draw this line one. When the grains are touched the end of the line, after then we are considered as the average accuracy of size of the grains one. So it is the intercept method. Sixth one is planning metric method. Planning metric method. In planning metric method, a circle or rectangle of 5000 square mm is inscribed on a photomicrograph with a suitable magnification so that at least 50 grains in the field will be counted among. So first one is see here. So first method, comparison method, we have the one standard formula, the American Society ASTM standard formula we have. By using this formula, we are counted the grains one. So capital N equal 2 for n minus 1 is the comparison method formula. After then intercept method one, we can draw the straight line. When the straight, we can draw the one straight line. The straight line end of the touch the grains one. After then we are counting off grains. So 3 times we are consider the exponent one. After then we are consider the accuracy of size of the grains we are considered. So next one is in planning metric method. So what we how we find out the grains means, see here in the planning metric method a circle. So first one is formula, first method is formula one. So second one is line one, third one is circle one. You can draw the one circle one, the circle rectangle of, we have the diameter also, the circle diameter 5000 square mm is inscribed on a photomicrograph with a suitable magnification, so that at least 50 grains in the field to be counted. So it is the planimetric method. The sum of the grains in the field plus, how can we consider the total number of grains? Means the sum of the grains in the field plus half of the grain intersected by the circumference of the area given the total number of grains within the area is called as planimetric method. So it is the how to find out the grains in a solid body in planimetric method and method. So the sum of the grains in the field plus half of the grains intersected by the circumference of the area given to the total number of grains within the area. So it is the grain size determination one. So it is the formula one, one by one, intersecting with the comparison grain size determination one, comparison method, intercept method, and planimetric method. So it is the grain size determination. So comes to the next topic one, equilibrium diagrams. Equilibrium diagrams. So our equilibrium diagrams are we can call as phase diagrams. So comes to the phase. The phase is a homogeneous portion of a system one. The phase is a homogeneous portion of a system is called is a phase one. So what is the second point one? Having some compositional properties throughout its volume is known as phase diagram one. So the phase is a homogeneous portion of a system, and simultaneously in this homogeneous portion of a system have the some composition and properties throughout its volumes is known as phase diagram. So next point is a phase can be solid, liquid or gas. The phase maybe it may be solid or it may be liquid or it may be gas one. So that one we can call as phase one. Next one is phase can be pure substance or solution one. Phase is a it is a pure substance or it or substance or a solution one. We can call as phase is a pure substance or a solution one. So it is one of the point. Next one is a phase diagram is essential, a graphical representation of phase one. A phase diagram is the essential one. Why it will be essential means a graphical representation of the phase. It is a graphical representation of the phase. So how can we find out the phase means graphical representation onwards only we are find out the phase on the particular elements or particular metals one. So it is the introduction about the phase diagrams or equilibrium diagrams. See another point also. So phase diagram from a useful basis from the study of various metallurgical concepts. This phase diagram, what is the use of the phase diagram means based on these phase diagrams we want to study of various metallurgical concepts. By using this diagram we want to study about various metallurgical concepts. What is comes to the next point one, such as melting, solidification and structure changes produced by heat treatment one. So what is the next point means such as melting, solidification. Melting is one of the process one. So next one is solidification process and the structure changes produced by heat treatment one. Structure changes produced by heat treatment. So how the structure will be changes by the heat treatment process means some example where we can take the one solid body. When we apply the heat on the solid body, automatically what happen when the temperature is we are increasing the temperature, automatically the solid body structure will be changes slowly one. Some example we can take the one plastic cover, just we can heat within fraction of seconds what we observe the structure will be changed totally one. That is the best example of the heat treatment one. Next one, the state of next point, the state of given system under equilibrium condition one, in which there will be no changes within the time. Therefore, a phase diagram is also called as equilibrium diagram one. So the stage of a given system under an equilibrium condition. Equilibrium condition or we can call as slow cooling one. In this equilibrium condition onwards, in which there will be no change with the time one. Under slow cooling process one, there is no change within the time one. After then, the phase diagram also we can call as equilibrium diagram one. In this condition only, we can call a phase diagram also we can call as equilibrium diagram. Which condition? Under equilibrium condition onwards, no change with the time one. After then only we can call phase diagram also we can call as equilibrium diagram. Is the brief introduction about the phase diagrams. So it comes to the next slide one. Gibbs phase rule. In this phase rules one, that is the first one is Gibbs phase rule. The English physicist William Gibbs in 1875 to 1876 onwards, he find out this some rule. So what is that rule, and what condition onwards the rule will be applicable means? See here, it describes the mathematical relationships for the determining the stability of phases present in the material at equilibrium condition one. So how that it is a mathematical relationship, Mama. Totally the rule is a mathematical relationship for the determining the stability of the phases. So what we find out means in this rules one, we are find out in the stability of the phases present in the material at the equilibrium condition. At the equilibrium condition, in the stability of the phases present in the material one, we are find out the phases. So this one we can call as Gibbs phase rule. Gibbs phase rule is nothing but it is a mathematical relationship determining the stability of the phases present in the material and equilibrium condition one. So in these conditions, in this present material onwards only we are find out the stability of phases one. So this one we can call as Gibbs phase rule. How can we find out the Gibbs phase rule means? See here, which can be present in the equilibrium in a given system one, P plus F equals C plus 2. P plus F equals C plus 2. So any one metal one, we are find out the phases one. Gibbs phase rule are used to find out the phases. Simply one line. What we call as Gibbs phase rule means Gibbs, by using the Gibbs phase rules one, we are find out the phases in the present material one at the equilibrium condition one. This is we can call as Gibbs phase rule. By using the mathematical formula, P plus F equals C plus 2. What is the meaning of P? P is the number of phases present in the equilibrium one. So next one is C. What is the F? F is the degree of freedom in the system one. What is the C1? C is the number of components. What about 2? 2 is the number of external factors. External factors is nothing but temperature and pressure one. See here. So P plus F equal C plus 2. P is the number of phases. F is the degree of freedom. C is the number of components one. So 2 is represent the external factors, temperature and pressure one. So it is the Gibbs phase rule one. See here another point one. Most binary phase diagram used in material science are temperature and composition diagrams in which pressure is kept constant, usually at one atom one. Is called as Gibbs phase rule. So see here Gibbs phase rule another condition also. P plus F equals C plus 1. P plus F equal C plus 1. How we consider the P plus 1 is equal C plus 1 means under, see here under condition when the pressure is kept constant, usually 1 atmospheric pressure one, after then only we can choose P plus F equal C plus 1. Here 1 represent the temperature only. So see here 2 is nothing but number of external factors, temperature and pressure one. But comes to this condition one, so P plus F equals C plus 1 means here pressure is constant, pressure is kept constant, of then only temperature will be considered. So when it will be happen means mostly binary phase diagrams used in material science are temperature and composition diagrams in which pressure will be constant, usually at 1 atmospheric temperature one. So after then only we can use P plus F equals C plus 1. Binary phase diagrams only we can use P plus F equals C plus 1. So what is the next topic is these are the rules one Gibbs phase rule. P plus F equals C plus 2. P is called number of phases. F equal degree of freedom. C is nothing but number of components. 2 represent the temperature and pressure one. External factors, number of external factors, that is what is the external factors mean temperature and pressure one. So the mostly binary phase diagrams when the pressure is kept constant, what is the formula means P plus F equals C plus 1. P is the number of phases, F is the degree of freedom, C is nothing number of components, 1 represents the external factor, so that is the at constant temperature one. At constant pressure onwards we can choose temperature only. So that's why we can write here 1. So next one is construction of phase diagrams. What is the construction of phase diagrams mean? The phase diagram are usually floated with temperature and alloy composition 1. So phase diagrams are usually floated with temperature and alloy composition. So phase diagrams is mainly depending on the temperature and alloy composition one. So based on these condition onwards, your construction will be done on phase diagram one. So comes to what is the second point, means the data for construction of phase diagrams can be obtained by the following methods. How can we consider the data, means by using these methods we have find out some data on the phase diagrams, construction of phase diagram. What are the methods, means see here, first one is thermal analysis one, second one is metallographic method, third one is X-ray diffraction one. X-ray diffraction. These are the construction of the phase diagram. We can find out some methods. Okay, Amma. So first one is thermal analysis one. What is the thermal analysis? Thermal analysis involves drawing of cooling curves for different composition one. Thermal analysis involves drawing of cooling curves for different composition onwards. The thermal analysis will be useful one. So in what is under cooling one, cooling curves for different composition onwards only thermal analysis will be useful one. Next one is metallographic method. In metallographic method, what happening means, in the metallographic method the alloys samples are heated to different temperature and kept at the temperature for sufficient time to achieve the stable structure one. In metallographic method, what can we are doing means, how we are constructing these methods means, in the metallographic method the alloy samples are heated to different temperature. The alloy samples are, what we can do means, metallographic method means we can take the one alloy and heat it to the different temperature and kept at the temperature one for sufficient time to achieve the stable structure one. Some example one, we can take the one iron metal one. In this iron metal one, so the hardness is lower one, hardness is very low, or brittleness is very high. So how can we increase the hardness? How can we reduce the brittleness? Means by go to the heat treatment process. By go to the heat treatment process, we can heat for different temperature onwards. After then we go for cooling system. We can cool the iron metal. After then we can check how hardness will be increased, how brittleness will be reduced. So it is the metallographic method. In metallographic method, we can choose for any alloy and heat it to different temperature and kept at the temperature for sufficient time and heat the metal with sufficient time. After then what happened to achieve the stable structure one. So this one we can call as a metallographic method one. So when we are heating the different temperature at a sufficient time, after then only we can get the stable structure one. After then what happened, it is not a stable structure, unstable structure. So temperature, when the temperature will be increasing, automatically the structure will be changes also. This is the metallographic method one. What is the third one? Metallographic method one. So see here, they are cooled rapidly to retain the high temperature structures. When they are cooled rapidly to retain their high temperature structures. So when we are cooling, we have the slow cooling, faster cooling also, and rapid cooling also. In rapid cooling one, what happens means, when we are heating the alloy one and we can cool for rapid cooling one. So after then what happens, to retain their high temperature structures one. So it is the metallographic method one. So see here another point one, the microstructure are studied using the microscope one. So here in metallographic method one, what is the procedure means, see here, one alloy we are heating different temperature, one alloy we are taking one alloy and heating different temperature, and we are heating for sufficient time. Sufficient time we are heating different temperatures we are using and heating sufficient time. After then what we are doing, and we are cooling that metal one, automatically it retain their high temperature structure one. Automatically we can get the one structure one. How can we see these structures means, to go to the microscope only. The microstructures are studied by using the microscope one. So it is the metallographic method one. Metallographic method. So next one is X-ray diffraction one. It indicates the appearance of new phases and is most useful in determining the limits of solubility at different temperature one. So what is the X-ray diffraction main role is means, it appears the new phases. When it appears the new phases and is mostly useful in determining the limit of solubility at different temperature. And main useful is determining the where we are determining means solubility. When we are determining the limit of solubility at different temperature onwards, the X-ray diffraction will be useful one. So next one is The next one is so this is my today class one. So once again I am revisioning, once again listening here. Today class one. Intermediate life phase one. First topic is intermediate life phase one. So what are the, it is intermediate phase one. What are the different types of methods means here? So see here, intermetallic compound one. First one is, second one is interstitial compound one. Third one is alternate compound one. So these are the intermediate ally phases. So next one topic is next topic is grain size determination. Grain size determination. Some example one. So in solidification process one, so the grain size, the grain will be formed. So how we want to, how we find out the grain size means, we have some methods. By choosing these methods, automatically we are find out the grain size one. So how can we find out? Generally we have the three types of methods. The first method is comparison method, second one is intercept or Hein method, third one is planimetric method. So this is a comparison method we can use for formula capital N equal 2 power n minus 1. By using the standard formula, after then we can find out the grains one. Second one is we can draw the one straight line. After then we find out the number of grains one. Third one is draw the one circle one. So that circle based on to find out the number of grains one. So next one is the equilibrium diagrams one. Equilibrium diagrams are we can call as phase diagram. Phase diagrams. So in phase diagram one, after then next topic is Gibbs phase rule. In phase diagram, the first topic is Gibbs phase rule. Gibbs phase rule, it is one of the mathematical relationship for determining the stability of the phases one. So the stability of the phases, how we are find out it means P plus F equals C plus 2. P plus F equals C plus 2. P is the number of phases one, F is the degree of freedom, C is the number of components, 2 represent the external factor. So external factors, what are the two external factors means temperature and pressure one. Comes to the some condition onwards.